Okay, you guys, we're now going to work through exercise 2-3 on page 111 in your textbook. And we're going to look at something the book refers to, and something that's actually called economic order quantity. And what we're trying to determine with economic order quantity is given the amount of materials a manufacturer needs during the year, and given that cost per unit of material. We'll be given those two amounts, and then we also need to know the cost to place each order. So there's going to be some cost associated every time we place an order. And then we need to know the annual carrying cost per unit of materials. And what we mean by carrying cost could be just the cost to store the materials, the cost of holding them in inventory. Could be some interest cost associated there too. And so I thought I would work for you exercise 2-3 here in the video. And then for homework, you'll complete exercise 2-2, which is a very similar one. A little bit of mathematics involved in this one, really. We're going to take the square root of a number that we determine, but Excel will do that for you. Also, all your calculators pretty much have a square root button on there. So, economic order quantity, EOQ stands for economic order quantity. And your formula for economic order quantity is given here in the template. It's the square root of a fraction. In the top half of the fraction, you want to multiply 2 times the cost of placing an order and times the number of units required annually. Okay, and then in the bottom half of the fraction, we're going to divide by the annual carrying cost per unit of inventory. Alright, so there's our fraction. The top, we're going to multiply 2 times the cost of placing an order times the number of units they need annually. Number of units of direct materials. Then we'll divide by the annual carrying cost per unit of inventory. Then we're going to take the square root of that number to get the economic order quantity. What this is telling us, you guys, is given all these constraints or variables, how many units of the item should they order at one time? Each time they place an order, how many units of the raw materials inventory should they order to minimize the cost of placing orders and to minimize our annual carrying cost? And this is just a mathematical formula that someone way more intelligent than myself has worked out at some point in the past, and it holds up. It's a good way to calculate it. You just have to know these different components of the formula. So let's read through exercise 2-3 on page 111. They say SoCal Company predicts it will use 225 gallons of material during the year. The material is expected to cost $10 per gallon. So some type of liquid material we're dealing with here. It anticipates that it will cost $40 to place each order. So there's their cost of placing an order, $40 each. The annual carrying cost is $2 per gallon. Okay, so our annual cost of carrying a gallon in inventory is $2 per gallon. Okay, A, determine the most economical order quantity by using the EOQ formula. Okay, so we'll just start with filling in all these amounts. On C, the cost of placing an order is $40 per order. Okay, N is the number of units required annually. Well, that was 225,000 gallons. And K is the annual carrying cost per unit of inventory. Well, that's $2 per gallon. Okay, so our economic order quantity, you guys, I'm going to calculate it over here to the side. Okay. So first I'm going to calculate the top half of this fraction. 2 times the cost of placing an order times the number of units required annually. Alright, and that's the top half of our formula that we're going to take the square root of. So I'm going to say it's equal to 2 times, and you can punch this in the calculator. I just like doing it in Excel. 2 times C, with C being that $40 per unit. I believe I'll just put the amounts in each time. 2 times C, which was 40, times N, which is number of units required annually. That's 225,000. Okay, so the top half of our formula comes out to 18 million. And again, that was just 2 times the cost of placing an order, which is 40, times the number of units required annually, which was 225,000. So it gives us 18 million in the top half of the formula. Then we want to divide that number by the annual carrying cost per unit of inventory. Okay, so that equals our 18 million divided by our $2 carrying cost per unit of inventory. So that gives us $9 million. Okay, so that's what we get when we divide out this part of the formula. 2 times the cost of placing an order times the number of units required annually divided by the annual carrying cost per unit of inventory. We get 9 million. Alright, our economic order quantity is going to be the square root of 9 million. Or what times itself would give you 9 million. Well, I'm going to put that in as, to get the formula to come up here, I put SQ, and then see this one, SQRT, returns the square root of a number. That's the one I'm going to pick. We want the square root of this number. And that's 3,000, which just means 3,000 times 3,000 equals 9 million. That's what square, I'm sure you're all aware of that, but that's what the square root of a number is. What times itself gives us that number? Well, 3,000 times 3,000 gives us the $9 million. Okay, so our economic order quantity here would be 3,000 gallons. And then in B, they first want to know how many orders are we going to place during the year. Well, if we're going to order 3,000 gallons every time we place an order, and for the year we need 225,000 gallons, that's just going to be equal to 225,000 divided by the number of gallons we're ordering each time. That means we're going to have to place 75 orders during the year. 3,000 gallons each order. Our annual usage was at 225,000. I'm not sure why they're wanting that one again. Our economic order quantity we can pull from up here. That's 3,000. Alright, our ordering cost. Well, we're placing 75 orders during the year. Each order cost, the cost of placing an order is $40. So our ordering cost would be equal to $40 times the 75 orders. So our annual ordering cost is $3,000. I really don't like that came out to $3,000 because that's also your economic order quantity. But now remember, that's 3,000 gallons. This one's $3,000. It's just coincidental that those two came out to the same amount. They typically would not. Now carrying cost. Okay, now this one we need to talk about for a second. You guys, on the day an order comes in, we're going to have 3,000 gallons of raw materials, whatever they're working with here. on the day that order runs out, or when we've used it all, we'll have 0 gallons. So the average number of gallons we'll have in a given period of time would be 3,000 plus 0 divided by 2, if that makes sense. I hope it does. So what we wanted to determine carrying cost, we want the average number of gallons that we would be holding on a given day. Well, on the day the order comes in, that would be 3,000. On the day we run out of that order, it would be 0. So the average number of gallons would be 1,500. So I'm going to say 3,000. This is going to seem ridiculous. Plus 0. 3,000 is the number of gallons we'll have on the day we receive the order. 0 is the number of gallons we'll have on the day we run out. Add that together and divide by 2. I'm going to come back here and put in a bracket. Alright, that gives us the average number of gallons that we're holding on a given period of time. Okay, the average number of gallons would be half of your economic order quantity. Because on the day the order comes in, it'd be 3,000 gallons. On the day we run out of that order, it'd be 0. So the average number of gallons that we're holding on a given day would be 1,500. Now, I know you're thinking it's only going to be one moment in time when it's 1,500, but the average number over that period of time would be 1,500. We want to multiply that times our carrying cost of $2. I'm not certain that this formula is going to work out, but if not, we'll try it a different way. Yeah, problem with my formula there. Let's do it over here to the side. What we're saying, let me just put this one over here as well. Okay, what we're saying is, first, we want the average number of gallons in inventory on a given day. Okay, the average number of gallons in inventory on a given day would be equal to 3,000, the amount we're going to order each time, plus 0, which is meaningless, divided by 2. Okay, so 1,500 gallons is the average number of gallons we'd have in inventory. So what we'll do to get the carrying cost, we'll take that average number of gallons in inventory on a given day, 1,500, times our annual carrying cost per unit of inventory, $2. And that one comes out to 3,000 as well. Again, that one's unrelated to your EOQ or to the ordering cost. They just, whoever wrote this problem just had a fondness for the number 3,000, I guess. Now, total order and carrying cost for the year would be equal to our 3,000 plus 3,000. That's $6,000. What they're saying is, by using this economic order quantity, we're keeping this total order and carrying cost at a bare minimum. And we're also not running out of raw materials. Okay, you guys. Sorry for the little trouble with the formula on that one, but I hope that makes sense to you. If you have questions, please be in touch with me about it. But just work this one along with me. You'll have the template up for exercise 2-3. And then I think if you can handle this one, the exercise 2-2, the homework problem, should just be a little review of this. Please be in touch if you have questions. Thank you.